On today's episode, the USAF is looking for engines. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. Are you in the gas turbine business? Looking to pick up a contract? Well, the U.S. Air Force is looking for you, or more specifically, is looking for U.S. industry capability for a very big program, the F-35 Adaptive Engine Replacement Program, or FAER. The F-35 program is the most expensive military procurement program in history, with airplanes entering service in 2015 with 760 aircraft built to date. The program is huge, encompassing A, B, and C models for the USAF, the U.S. Marine Corps, and the U.S. Navy, with an overall planned aircraft purchase of 2,456 aircraft through 2044. The aircraft are expected to operate until the year 2070. With a projected service life of over half a century, it's natural the Pentagon would plan for considerable upgrades, including the engine, and the FAER is starting early with a request for information, a precursor to an RFP, which seeks to catalog capability statements from potential sources, including small businesses, including women-owned, veteran and service-disabled, and economically disadvantaged women-owned operations. The Pentagon is ultimately seeking a fully integrated propulsion system vendor to ship replacement-ready power plants for all three services, and a request for information is a way for smaller businesses to get their foot in the door into what will be a massive and long-running procurement program. The current F-35 engine is the Pratt & Whitney F-135 low bypass ratio turbofan with afterburner, with a rated thrust of 43,000 pounds. This engine, derived from the F-119 used in the F-22, uses a larger fan and is not designed for supercruise, instead using an afterburner with heat-masking materials for supersonic dash capability. The F-35B variant uses a modified engine that includes a Rolls-Royce-developed lift fan system to give the B a short takeoff and vertical landing capability. An alternative engine was proposed, the General Electric Rolls-Royce F-136, but that program was cancelled in December 2011 due to lack of funding. The current program, which was launched in 2016, seeks a variable cycle design with the goal of eliminating the classic problem of high-performance military jet engines: the need to optimize thrust and efficiency over a wide range of airspeeds, including supersonic flight. Major candidate technologies include tandem compressor fans with the ability to restrict bypass flow, or a mixed-flow turbofan with ejector, a low bypass ratio engine with an extended exhaust that ingests additional air to reduce the mean jet velocity of the exhaust for takeoff and landing. As a multirole aircraft, the F-35 is expected to perform over a wide range of airspeeds from effectively zero in hover to approximately Mach 1.6, a tall order for any airplane, let alone one which must stay leading edge for 50 years. So if you're a Tier 1 or Tier 2 supplier to the jet engine industry, or would like to be one, this could be the score of a lifetime. We'll keep you informed as the program develops. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.